Welcome everyone to our webinar on Controller Area Network Big Data Analytics. We shouldn't be making any product-related promises in this webinar. However, here is our obligatory Safe Harbor slide. As a very brief introduction, my name is Tony Lee and I've been with BlackBerry Cylance for about 3 years now, currently serving as VP of Global Services Technical Operations. I have over 15 years of professional security experience, starting in offensive security and red teaming, slowly transitioning to blue team and SOC build via my rapid prototyping and product integration background. I have a bachelor's from Virginia Tech in computer engineering, so if there are any Hokies listening, go Hokies. And I also have a master's in security informatics from Johns Hopkins. I typically have a research project or two in the works, and I enjoy writing about my digital adventures in the form of books, blogs, and white papers. I also contribute to tools in the security community such as Cybot, our open source threat intel chatbot, and also the forensic investigator Splunk app. This presentation will cover a brief introduction to our project, the components we used, some features we found beneficial, usage tips, our development process, and finally, how we can continue this research for everyone's benefit. Let's start with some food for thought. Have you ever wanted to visualize the data from your vehicle? Whether that's a car, a bus, a boat, a tractor, or even a tank? Well, we did too. If your vehicle could speak, what would it say? Could it tell you that it's about to experience a failure? The goal was not to make a specific system that could only interpret data from one car or one widget, but to build a scalable system that could adapt to many data standards. And that's no small feat. So we had to answer some questions that might help others in this journey, such as, what are the hardware options available needed to collect the data? Moreover, could this be accomplished using commercial off-the-shelf hardware, reducing our time to results? And could we make it with minimal software, mainly commercially available software, to do the heavy lifting with a bit of customization to achieve our goals? What protocols are available to send the data? What's most flexible? What's most secure? And can we interpret and visualize the data in real time, making this useful for troubleshooting and correction? Even if you stumbled across this talk and you think that it does not pertain to you, the truth is it probably does. CAN bus data is truly at the heart of many industries, including passenger vehicles such as trucks, buses, ships, and tanks, heavy machinery such as bulldozers, excavators, and everything that you wanted to play with as a child, and maybe still do. Industrial automation and mechanical control, such things found in manufacturing environments, building automation, elevators, escalators, which are now commonplace in nearly all offices. Medical instruments and equipment such as prosthetics, and the list really does go on. Okay, so if this does apply to your industry, what can you do with it? Well, we can give you some ideas, such as performance monitoring and predictive failure analysis, which could be achieved through proper collection, parsing, and displaying of the data. The performance monitoring itself could be used to improve existing versions of products and even make competitive products. Predictive failure analysis can be used to improve overall consumer safety and satisfaction, since the one thing consumers hate the most is when something breaks down unexpectedly. Security alerting and prevention, thwarting sophisticated attacks, resulting in customers that are more protected than ever. And finally, fleet management services, providing logistics insights and efficiencies, generating cost savings and benefits that everybody from the consumer to the company can see. Now let's talk components. Some of these will make more sense when you see the data flow diagram slides in a bit, but hang in there with us for now. As mentioned previously, we're striving to use commercial off-the-shelf components to lower the barrier to entry. In terms of hardware, we used CSS Electronics CAN Logger CL3000 to interface with the car and send the CAN bus data to a Microsoft Surface Go that was mounted in the vehicle. This was all transferred over a mobile MiFi and then onto the Splunk indexers for parsing and storage. We used an OBD2 to DB9 cable to connect the CL3000 to the vehicle, but you need to use a cable that matches the device that you're logging. For example, if we were collecting data from a tractor or a truck, we would most likely need a J1939 to DB9 cable. Fortunately, CSS Electronics sells the necessary cables and provides the pinout in case you want to make your own. For software, we initially used Windows to run CAN processing software called Canvas from CSS Electronics. However, after we started sending raw data to our analytics platform, we removed the Microsoft Windows requirement and now can use any operating system. For the analytics platform, we used Splunk because we're already familiar with the setup and some custom development via lookup tables and dashboards. However, you're free to use whatever you prefer. Similarly, we used a Splunk Universal Forwarder to get the CAN logger data from the Surface Go to send to the analytics platform. But again, use what makes the most sense with your analytics platform. And finally, publicly available conversion and decoding databases were loaded into Splunk to interpret the data. But this could easily be your proprietary decoding databases as well. Some may be asking why we selected the CL3000 as our collector of CAN bus data. Well, we had a number of success criteria that had to be met. We wanted to log from both OBD2 and J1939. We wanted to be able to control the output format to make data parsing a little easier. And since we're not with access to proprietary CAN bus decoders, we had to use a well-known method of interpreting car data. In this case, it was to have the CL3000 query the ECUs for the specific data that we needed. We also wanted to be able to scale the data collection by having multiple CAN loggers sending data to the same platform. And finally, we wanted flexibility in data transportation. And the CL3000 provides 3 possible modes. The first mode is access point mode, which enables the CL3000 to act as an access point for the laptop to connect. Since we're sending the data onto a Splunk instance that we're hosting in the cloud, we didn't use this mode because it didn't provide the internet access to do so. If we're keeping the data local, this method would have worked just fine. The second possible method is station mode. This allows the CL3000 to connect to an access point, which makes the files available via a web interface. We use this mode initially to understand the hardware and output options. However, we ended up using the third mode, called push mode, because it allows the CL3000 to connect to a hotspot which we had in the van and push data via FTP to a Surface Go. This mode is ideal for hands-off automated sending of data. So what does all of this look like? Our first prototyping efforts had the CL3000 connected to an in-vehicle MiFi so it could wirelessly send the data to the Surface Go. Then once the data landed on the Surface Go, we were running CSS Electronics Canvas software to process the data using their decoding tables. Then we used Splunk's Universal Forwarder to send the already decoded data to the analytics platform for parsing and displaying. This was a great first step, but this data flow relied heavily on local decoding and processing, making it more expensive to scale. The second prototyping effort shown here used the same method to gather the data from the vehicle and send it to the Surface Go. But instead of using Canvas to decode the data locally, we forwarded the data to our cloud-hosted analytics platform. It was then in Splunk that we applied the lookup tables to the raw data to perform the decoding to human-readable information. The advantage of this data flow is that we can use cheaper hardware in the car since we don't need to spend the resources to decode it locally. Our end goal was to get to the third data flow, which involves sending data directly from the CL3000 to our cloud-based analytics platform over a secure protocol, then having the analytics platform perform all the heavy lifting. Unfortunately, the hardware available at the time was not designed for this data flow. However, we're now working with CSS Electronics' latest hardware called CanEdge 2, which is designed to send data from the CAN logger directly to the cloud. Our work with this hardware is still ongoing. Now that we understand how the data gets to the analytics platform, let's look at what we did when we got it there. The first step was to parse the raw data. This raw data can be seen in the bottom left-hand corner of the screenshot. The regex responsible for parsing it is shown at the top, and then the corresponding parsed fields are shown in the bottom right. You can see that we are parsing out the number of bytes, service, PID, and the registers A through E. The next step is to load the conversion tables into Splunk that can not only be used as a tool in a dashboard, but also be applied to the raw data so it can more easily be interpreted by humans. The conversion tables will depend on the data that you're trying to decode, but this provides the greatest flexibility in adapting this process to meet your needs. Next, we're applying the lookup table to the raw data that we requested, which translates into throttle position, vehicle speed, engine RPM, and MAF airflow rate. Now we know which registers we need, the formula to apply, and the resulting units. After applying the proper formula, we can plot the data over time as a line graph to better visualize what happened in the real world. In this case, we plotted the speed of our 2015 Toyota minivan from our house to my in-laws. Now that we have the hang of plotting vehicle speed, we can plot the other data we requested from the ECUs, such as RPM, throttle position, and mass airflow rate. Best of all, these can be plotted over the same time period and even on the same graph if desired for data correlation. So in conclusion, the roadmap is as robust as it could be due to the many applicable industries. This research hopefully provided some ideas and the framework to get people started. The real power will be in loading more conversion databases and developing use cases to solve your real-world challenges. We're also experimenting with newer hardware such as CanEdge 2 that has the ability to write directly to the cloud via S3 buckets. CAN Cloud from CSS Electronics is a web and tremendous promise, especially for fleet management service operations. But without further ado, let's demo the results of our research. The CAN bus data in this demo was collected from the OBD2 port of a 2015 Toyota Sienna minivan as it was driving. The CL3000 sent the data to a Surface Pro mounted in the minivan. The Surface Pro then sent it on to the Big Data Analytics platform, Splunk in this case, for parsing, decoding, and displaying. Current research skips the Surface Pro and sends the data directly to the cloud. Note, if you try this at home, ensure that you have a dedicated driver if you're viewing or manipulating the data in real time. Safety first, folks. Now, let's look at the data in the app. In the first dashboard shown here, you can see the raw, unfiltered CAN bus data collected from the OBD2 port. Raw event details are shown at the panel in the bottom of the screen. Statistical analysis on the ID, service, and PID are shown at the top, while we're plotting ID and PID over time in the center. Because raw CAN bus data is proprietary knowledge of the auto manufacturers and varies between makes and models, we would need to load a proprietary decoder to make sense of the raw data itself. However, the statistical analysis that we're performing here could also be used to reverse engineer the proprietary CAN bus decoder. The next dashboard is the same CAN bus data, but filtered on IDs 7E8 and 7EF, indicating an ECU response to our queries. One of the benefits of selecting CSS Electronics CAN Logger 3000 is that it can query the ECUs for data that is easily interpreted using a known OBD2 PID decoder. In this case, the CL3000 was configured to query for throttle position, MAF airflow rate, vehicle speed, and engine RPM. Similarly to the previous dashboard, we map these PIDs over time in the panel to the right and show the raw individual events at the bottom of the dashboard. Before we leave this panel, notice that the PID is part of the event packet shown at the bottom of the screen. Also note that it is mapped to a description in the mid-left panel. Next, we'll see how this mapping and interpretation to human-readable information takes place using a decoder database. The first decoder that we'll examine is commonly available from Wikipedia or other sources. In fact, we found a CSV version of the data on GitHub, which was easily loaded into Splunk as a lookup table. The data in the lookup table contains the PID in hex, the number of bytes, human-readable description, expected ranges in a minimum value and a maximum value, as well as the units and formula needed to calculate the value using the data in the registers of the raw events. We added filtering capability in this lookup table to use as an interactive tool, but we're also applying this table to the event data so we can plot it in real time. Let's look at some of the known received data that we should be familiar with by now. So for example, we can search for MAF in the wildcard filter. Or how about speed? We can also search by the PID in hex, such as 0C or 11 hex. Notice that in each of these cases, we can see the PID, the number of data bytes, the description, units, and formula that we're going to apply to the events. We have other decoder databases loaded into Splunk that are generously provided by CSS Electronics. The first will help decode FMS bus data if that is your goal. The next decoder will help with FMS truck data. These two are just other examples, but we can load any decoder database into the app to make it more flexible in receiving a variety of vehicle data. Now that we have shown the raw CAN bus data, the requested data, and the decoders, let's put it all together to show the real power and usefulness of this project. In what we are calling the core 4 graphs, we took the 4 pieces of requested data and applied the formulas per the decoder, and then plotted them over time. If we were automotive engineers or automotive security analysts, we could use this data not just from one car, but millions of them. But why would anyone want to do this? By modeling and understanding the data at mass, possibly using machine learning, we could potentially predict vehicle failures. Now, wouldn't it be nice if your car could send you a message to go to the mechanic before the car broke down, throwing off the rest of your day and potentially causing more damage to the vehicle? Of course you would. This is just the tip of the iceberg with so many industries and potential applications for logging CAN bus data. So thanks for listening, and reach out if you're interested in learning more or partnering with us on your next great idea. Now we will open it up for any questions that the audience might have. If we do not get to your question during the webinar, please feel free to email us via the contact info in the white paper, and we'll get back to you. Thank you.
We have a few questions that have come in. Our first one is, can this sort of logging be accomplished with other hardware or software?
Good question. Of course, the hardware and software that we chose for this research project is just one example, mainly just due to our familiarity with the software and the success criteria of the hardware. But of course, you're welcome to pick whatever makes you feel most comfortable and increases your productivity and gets you to your goal fastest.
The next question we have is, other than Splunk, what other analytics platforms have you experimented with?
I mean, Splunk was our main target to begin with. We understand development, the lookup tables and everything, but I mean, there are other popular ones such as Elk Stack. But yeah, if you're an Elk Ninja, I would say give it a go and let us know what the results are. Yeah, theoretically, any analytics platform would probably do the same. We definitely recommend selecting something that has the lookup capability, especially automatically applying it. That way, it's not just machine data, it's human readable data.
Thank you, Tony. Another question has come in. Do you recommend teaming up with data scientists to perform the analytics?
Absolutely. So I'm a firm believer that you can't know everything. So if you have access to some data scientists who can help apply algorithms and ultimately increase the value of your project, it'll certainly be worth it. So hopefully you have some PhD math brains surrounding you that you can tap.
Our next question is, do you have any future projects in mind that would benefit from this work that you've shown today?
Yes, I've actually always wanted to log data from a commercial tractor or a boat or a tank, especially anything that's autonomous. I think those are all interesting use cases. And anything that's in a manufacturing site, that's always interesting. I mean, if you consider all of the pieces of equipment that log data in some form or fashion, it just makes an interesting use case, not just from performance, but also security as well.
Tony, this question came in twice, is how do we go about getting additional resources that may be available from the materials that you've shared today?
Yes, so I believe we're going to be sending out a link to the white paper at the end of this. So you should receive that via email. And then I believe the recorded version of this will also be available.
I got one more question here. Do you have any similar projects more focused on IoT?
It's scheduled right now, nothing, but I would love to hear what your ideas are. So if you can, just reach out to us. There should be an email address in the white paper that will route to me. If you want to reach out directly as well, it's just tony.lee@cylance.com. And I'd love to hear what your ideas are.
Oh, we have one more afterward. He's a Splunk Ninja and would love to talk to you, so I'll get you that information afterwards.
Outstanding.
Tony, thank you so much for your time and dedication to this project and sharing this valuable information. And thank you all for attending.